Hello, everyone. My name is Michael, and today we're going to be looking at problem 10 from the team round of mathleague.org release 12512, which it was the November 2024 middle school qualifying round. Let's take a look. Alice creates the quadratic function p of x equals ax squared plus bx plus c using real coefficients a, b, and c such that it has real roots p and q. Bob is inspired by Alice, so he creates the quadratic function q of x equals a plus 1 times x squared plus b plus 3 times x plus c plus 2, which has roots p and 2q. Given that p over q is equal to 6, what is the sum of all possible values of a? So let's take a look at this. The first thing to note is that there are way too many variables for us to solve for all of them at the beginning anyways. So let's start by rewriting p of x and q of x. P of x can be written as a, the leading coefficient, times x minus p times x minus q, because the roots of p of x are p and q. Q of x, similarly, has a leading coefficient of a plus 1 and roots of x minus p and x minus 2q. So, using this, right, we now have alternate forms for p of x and q of x. Now let's do something interesting. Let's set a new function. We're going to call it, say, r of x. Doesn't really matter what you call it, just don't use p and q again, probably. And I'm going to let r of x equal q of x minus p of x. Now we're going to calculate this two ways. The first way we're going to calculate it is by using these factorizations, which is a plus 1 times x minus p times x minus 2q minus a times x minus p times x minus q. From this, we can factor out a factor of x minus p, and then it's just a plus 1 times x minus 2q minus a times x minus q. And if we do the algebraic simplification, which I'm not going to bore you with, this turns into x minus p times x minus aq minus 2q, which we can more nicely write as x minus p times x minus a plus 2 times q. All right, now we're also going to do this subtraction by just doing q of x, which is a plus 1 times x squared plus b plus 3 times x plus c plus 2 minus p of x, which is ax squared plus bx plus c. And if we do this, this just comes out to x squared plus 3x plus 2, which factors as x plus 1 times x plus 2. So that means that since these two expressions represent the same thing, they have to equal each other. So we have two possibilities, right? The first one, right, is that x minus p is equal to x plus 1. Kind of like that. Okay, so if minus p is equal to x plus 1, then p equals negative 1. Now, note that p over q is equal to 6, so p is equal to 6q, or q is equal to 1/6 of p. So that means that q, in this case, is negative 1/6. Now, we also know that, I'm just going to zoom out a bit so we have more space. So we also know that x minus a plus 2 times q has to equal x plus 2. So that means that a plus 2 times q has to equal negative 2. And if we solve for this, plugging in q equals negative 1/6, we'll get a equals 10. Similarly, if we do that with our other case, if we have x minus p equal x plus 2 instead of x plus 1, then it'll give us p equals negative 2. Since q is 1/6 of p, that means q will be negative 1/3. Solving again, x minus a plus 2 times q this time equals x plus 1. Since the factors have been flipped, we know that a plus 2 times q is equal to negative 1. Q being negative 1/3 gives us a equals 1. So here we have our two possible values for a. If we add those up, we're going to get 10 plus 1 equals 11, and that is our answer for this problem. Thank you all for watching. I hope that was informative, and we'll see you again next time.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.